So throughout previous lessons, we've been looking at a real harness like Claude Code, a real harness out there in the real world, and comparing, or rather, looking at how our components exist in these harnesses. We looked at Claude Code, we looked at Cursor, we looked at Codex too. We also looked at Codex. But now, this video is for you to see everything all at once within a single popular harness. And I've chosen Claude Code because it's the most popular. Claude Code Cursor, I don't know which, I don't have the numbers, but I believe currently Claude Code is more popular than Cursor. So we're going with Claude Code. So we're going to be looking at each of the components that we've looked at and how Claude Code implements these components. Just to kind of decompose a real world agent into the components that we just discussed. So first is the loop. By the way, if you like this diagram, yeah, I do too. Gemini did this. This was from Nano Banana. I was trying to draw out this, then I just remember that Nano Banana is quite good at creating diagrams like this. So I just basically took my notes and dumped it into Nano Banana, and Nano Banana took my notes and gave me this diagram. I had to do a little bit of tweaks, but yeah, I still got something good, and that's why you see this AI symbol here. Anyway, yeah, just giving you a background just in case you want to create this type of diagrams. So first we have the loop. And like we know, the loop is the agent's outer orchestrator, is the agent's main orchestrator. Mostly uses the React pattern. That's the most popular pattern. That's also the pattern we're going to start with in this harness build, in this course, and we'll continue to improve on it. And what this does is that it keeps calling the model. It keeps calling the model until the task is done, until there is there's always a condition that needs to be met. So we have to check. So you say it keeps calling until the task is done. So there has to be a criteria, a completion criteria, that will continue to check after every turn. If it is met, the result is going to be returned. If it has not been met, then we keep calling this React thought, action, and observation process. So that's what the loop does. It calls the model, decides action, execute tools, and inspects the tool, checks whether the result is gotten or a step budget has been hit, because that's one thing that you also want to make sure that you have a step budget. You don't want this loop to continue forever. So for every task, you want to give it a step budget like 15 or 20 or whatever you feel is reasonable for the subtasks to be completed and for you to get something reasonable. And if it doesn't complete it in those number of turns, it will just package what it has and return it as the result, so that can be passed to the next execution, which is fine. That one will just take off from where the previous one stopped. So that's the loop. Next, we have tools. Claude Code has simple tools. That is very simple tool surface, as we've discussed. Tools like read, bash, glob, grep, a simple task management tool for writing out your plans when you give it a task. It also has an MCP connector, and Claude's main ideology is to have simple tools that are composable, so that you can get so many customizable tasks done using simple tools. It's easy to compose simple tools than to have all these bespoke tools, and you have to keep creating a bespoke tool for every single task that you want to perform. So these are Claude's basic tools, and it also adds more of these base tools that are easy to compose. That is basically how Claude operates. And you can always add your own skills. More on that later. So these tools are basically sharpened for specific tasks, and like I said, easy to compose. Then we have the context. And Claude implements this with different strategies. There's the system prompts that we are familiar with. We also have the conversation history. We have the tool results, which are important. Then we have this thing called agents.md, which is one of the simplest ways that harnesses implement long-term memory. Is basically a file. So it's not like you have like a vector store and RAG processes and all that. No, it's just a simple file where instructions for the task is going to be defined, and also this file gets updated with new information that needs to be persisted as the task runs. Now, Claude on its own actually implements this as Claude.md. That is the agents.md version that Claude uses, but you can still use agents.md in Claude. You can then use your Claude.md to refer to agents.md, because agents.md is actually the main standard, and we're going to be building out a system for that in our harness too. agents.md is the main standard used by Open Code, used by Codex and different other analyses out there. But Claude has to be stubborn, so they went with Claude.md. But you can always refer to agents.md within your Claude.md so that you can continue to use agents.md, which is the standard. Then you also have art files. You can also pull files in with your art references. And yeah, this is how context is assembled in Claude Code. Then we have our environment, the Claude Code environment, which is basically your local machine. Your file system. Claude has all the tools for reading and writing to your file system. It can also run shell. It can also run in your shell. That's a bash tool to run in your shell. We've talked about the MCP connector, which also comes from tools. As we have looked at earlier, the environment is just a playground for tools. Environment is basically just a playground for tools. And you can make that environment remote, you can make it scoped, and you can also make it your entire system, which is not advisable, but sometimes you just gotta do what you gotta do. You also make sure that you are getting destructive operations, which is something that Claude also does to make sure that your actual system is protected from any kind of shenanigans that your model might decide to do. Then we have memory. Short term and long term. Like I said, agents.md is one of the clean ways to implement simple long-term memory. Put your instructions, put instructions that need to persist, context about the project you're working on and stuff like that. You put that in your .claude directory, the .claude directory in Claude, where you can dump information like that. And you can have different layers of agents.md. We're going to be looking at that later. You can have different layers of agents.md. You can scope them to your repo, or you can have them at user level. You can even have them like at a system location on your system, so that every single project that you're running can actually inherit from those instructions. I think I saw that with Open Code. But we're looking at Claude Code here. So I believe it does something similar. You can have like system-wide instructions for every Claude Code instance that you spin up. Then we have the observability and log system. Claude Code will show you every tool call in the UI so that you can know what is going on. It also tries to collect its own information because it needs to debug when you ask it why something failed. But basically, the one you see in the UI is basically the tool calls that it is making. Every read operation, every edit operation, every bash operation is shown to you as it happens. So basically, this is Claude Code, and this is how it implements every single component that we've looked at. And I want to believe at this point you're getting kind of theory fatigued. So in the next section, we're going to start building out our harness.